All right, so today we're going to learn the constant and power rule, and you will be so tremendously happy because problems that took you 3 and 4 minutes are going to take you 30 seconds. So it's going to be a very nice rule to know. Now the first one is the constant rule. So this is just saying, of course, the derivative, notice this notation. Remember how we talked about dy dx was the derivative of y with respect to x. Well, sometimes they write it this way, and they have the what you're taking the derivative of kind of written like that. So with that notation, you're taking the derivative of y with respect to x. So this is saying the derivative of a constant, and that the derivative of any constant, if you think about the graph, a constant looks like that. The slope at any point will be 0, so the derivative of any constant is equal to 0. So that means if f of x is 7, then f prime will be 0. If f of x is e to the 4th, that's a weird constant, but nevertheless still a constant, then you also get 0. So that one's pretty easy. Now the power rule, here's where you're going to love because it's going to make your life so much simpler, is this power goes to the front and then you decrease the power by 1. And that's literally what I say in my head. I say power to the front and then decrease power by 1. So the derivative of x to the 8th, I bring the power to the front, would be 8, and then decrease the power by 1, and that would be 7. For 6x to the 5th, power to the front. So when I say power to the front, I multiply those two together. So 6 times 5 is 30, x to the 4th. And it's that simple. And so here's the deal. If there's a long string of things separated by plus, remember our properties of limits say that you could add the individual ones. So being that a derivative is just a limit, watch how quickly I can find that derivative without having to do the definition. Look at this one. 2x squared, power to the front is 4, decrease the power by 1. The derivative of 3x, there's really a 1 there, so power to the front, that's 3. X to the 0, which is 1, so I don't write it. And of course, the derivative of any constant is 0. So there's my derivative. I'm already done. What is this one asking? Really what this is asking, again, this notation is saying what is the derivative of this thing? That's what it's asking. So really it's asking the same thing as, hey, f of x is this, what is f prime? But just to make sure you understand that. Now, here's the deal. When you have 1 over x squared, you cannot take the derivative of a quotient without the quotient rule, which you don't know yet. And even still, when you know that rule, rewriting it is going to be much faster. So do you see that I could write this as, hey, what's the derivative of x to the negative 2? 1 over x squared is the same thing as x to the negative 2. So that would be power to the front, decrease the power by 1. But they won't leave negative exponents. So notice that the 2 stays, but the x to the third will go to the bottom. All right, so why don't you stop the video and try example 3. So here we go. Now don't be confused because this guy has t's in there. I'm just going to take the derivative of g with respect to t. Now let me rewrite this one. That first term is just really saying this. So again, you be smart about the rewrite. So power to the front, 4 times negative 1/2 is negative 2. t to the third plus power to the front, 3 times 3 is 9, t squared minus 2, and that's that. All right, so write the equation of the tangent line. So now we're going to do this problem that we've done before, but it's going to take us a lot less time, which will be nice. What do we need when we find the equation of a tangent line? We need a point and we need a slope. So f of 2 is going to be 2 plus 3, so that gives me 35. So our point is 2, 35. Now our derivative at 2, instead of having to use the limit definition, I will just find f prime of x, which is 8x cubed. Then f prime of 2, I can plug that in very easily and get 64, and I'm ready to go. It says tangent line, so y minus the y coordinate is slope, x minus the x coordinate. And that is the equation of your tangent line. So stop the video again and you try to do example 5. Next one. Now this one's a little bit harder because my function is a little more complicated, but the steps are going to be the same. What is f of 8? I'd plug in 8, remembering that to take a fractional power, I do the cube root of 8, which is 2. 2 squared is 4. 4 times 2 is 1/8. So my point is 8 1/8. And then the derivative, it might be helpful to rewrite f of x. Notice that f of x, if I wrote that and got it ready for the power rule, it would look like this. And so the derivative, I'm going to write this one out. Power to the front, so I'd multiply by -2/3, decrease the power by 1, so that means you subtract 1. So what do we have? We have -1/3 x to the, I'd have to change that to 3/3, so -5/3, which means it looks like this. So now find f prime at 8. And if I put in that 8, again, now that you know the drill, you have 2 to the 5th, which is 32 times 3, and this is -1/96. But this says normal line, so when I go to write my answer, I'm going to do y minus 1/8 is equal to 96 x minus 8. All right, 2 more. Determine the points at which f of x has a horizontal tangent line. When you see the word horizontal tangent line, you should think slope is equal to 0. In other words, f prime is equal to 0. So I've got to find f prime. Well, once again, I have to rewrite f of x because I have a quotient. So notice I could just divide, and these two functions are the same, except for at 0, but that's not going to be a big deal. My derivative by the power rule is 4x minus 3. And so I set 4x minus 3 equal to 0, and I get 3/4. Now I either write this or I say this. You have to tell your grader what equation you're solving, so you have to write one of those. You can't just jump from this to all of a sudden him. Now, unfortunately, I'm not done because it says points, so I have to find f of 3/4. So I'm going to plug that back in right there. So 2 times, if I square that, that's 9/16, minus 3 times 3/4 plus 1, and just do a little fraction work. So that's 9/8 minus 9 over 4, so that'd be 18/8 plus 8/8, and that's -1/8. So F has a horizontal tangent at 3/4, -1/8. All right, last one. Is this function differentiable at 3? Well, let's talk, remember continuity. Continuity, I'd test that first, because if it's not continuous, it's not going to be differentiable. So if I plug in 3, I do get 10 and 10. So it is continuous. But now I don't have to do the limit definition. Watch how fast you can do the derivative. The derivative of that top one is 4x, and the derivative of the bottom one is 5. Now look at when I write the inequalities, notice that I didn't automatically put the equal to there, because that would mean that the function is differentiable at 3. So I'd have to check that. But my checking is a lot faster. Just like I did it for continuity, if I put in the 3 here, the left-hand derivative is going to be 12. The right-hand derivative is going to, there's nothing to plug in, the right-hand derivative is 5, and those two things are not equal, therefore F is not differentiable at 3. So my point is, this piecewise, rather than doing the limit, you just take the derivative of each piece, but you do have to watch, you don't automatically put the equal to sign. You've got to check if the left and right derivatives are the same. All right, so that is the power rule. Good luck.